Hi, everyone. Thanks for joining our live data science demo today. We're so excited to have you join us and learn more about the Data Incubator and experience a great demo with us. So without any further ado, I'm going to hand it over to Raven to get us started.
Thank you. So welcome everyone. My name is Raven Lee and I am an enrollment specialist at the Data Incubator. We are a fellowship, scholarship, and placement company. We have promised you all an excellent info session that will be led by one of our instructors, Michael Cullen. Michael will link a notebook in the chat that he'll be using. Hi, Michael. Michael will be using a notebook in the chat that he'll be using during his demonstration. Please make sure you have access and can follow along. To start things off, I would like to give you a quick overview of our program and everything that we offer. Then I'll hand off to Michael, who will jump in our live demonstration, and he will leave some time for questions at the end. Please place all questions in the Q&A section, and we will answer them at the end of the presentation. As a reminder, our session is an hour long, so if we don't get to all of your questions today, please email us at admissions@the-Data Incubator, and we'll be happy to help you. What does the Data Incubator offer? The Data Incubator focuses on training people to become data scientists and analysts. Why is that important? It is really because data scientists have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a ton of different industries, ranging from tech to finance to retail to healthcare and many more. Every company has data and wants to use that data to drive value for them. What makes the Data Incubator different? There are a lot of other data-focused programs out there, so I'm sure you're wondering what we do at the Data Incubator that's a bit different. What we found is when you look at training, there are two different types: fast-paced and efficient, and slower and focuses on understanding and completion rates. University is one example where you will receive a more detailed understanding, but a lot of more time invested. On the job training is usually very quick and efficient, but maybe you're not understanding what you're doing. We've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced. You walk out the program knowing a lot about data science and data analytics and real-world business application, and with a deeper understanding as you'll get from university. All of our instructors are PhD and master holders and have completed this program and know how to provide that in-depth training that you are looking for. So just our program offerings. We are so excited to announce that our fall 2021 cohort will now be offering 4 data-focused programs. We'll be offering our successful full-time data science fellowship program and a more flexible version of that, our part-time data science fellowship program. We are also offering our part-time data analyst program and our new full-time data analyst program. So the program overviews. All of our programs are intense. They are built around hands-on data-focused curriculums. We offer both full-time and part-time programs, and both are packed with a lot of information and tools. All of our programs are thorough. Each week focuses on a different data science or data analytics tool or approach. In addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment, and so in each program, students will work on many projects that focus on the data tools you are studying. Additionally, all of our programs are very collaborative. We want students not only to work with their colleagues and instructors, but to also have opportunity to network and connect with our hiring partners. All of our programs are career focused. We have career coaches that help you succeed in your data-focused careers. You will not only learn how to present your best self by attending our career search workshops, but you will also have the opportunity to work with #1 resume writing companies to get you a polished resume and cover letter. Lastly, all of our programs are interactive. Every student in all of our programs are provided a Jupyter server for the duration of the course, so students can follow along in lecture and see and edit raw code that's being run. Students will receive immediate feedback via our interactive grader. Our full-time data science program. The full-time data science program lasts for 8 weeks with classes held daily. You can expect to spend about 40 hours per week in class and working on assignments. Here's an overview of our full-time curriculum broken down by week. And of course, if you would like a more detailed curriculum, or if you would like this curriculum, please email us. Our part-time data science program. The part-time program lasts for 20 weeks with classes held on Mondays and Wednesdays from 7 p.m. Eastern Time to 9:30 p.m. Eastern Time. Expect to spend 10 hours per week working outside of class. Office hours are available each week. You will receive the same excellent curriculum and training as our full-time program, but at a slower pace. The sessions are live and instructor-led, so you are still able to interact with your instructor and ask questions. Part-time data analytics overview. The part-time program lasts for 20 weeks and with classes held on Tuesdays and Thursdays from 7 p.m. Eastern Time to 9:30 p.m. Eastern Time. You can also expect to spend 10 hours per week working outside of class. Office hours are available each week. The part-time program is great for those who are working or still wrapping up their degree, as it will allow you to work full-time while advancing your data-focused career. You will receive the same excellent curriculum and training, but at a slower pace. The sessions are live and instructor-led, so you are still able to interact with your instructor and ask questions. The full-time program lasts for 8 weeks with classes and office hours daily. You can also expect to spend 40 hours per week working outside of class. The application process for this program is composed of basic information, resume review, and career goal-focused group interview. Throughout the course, you will work on many projects to demonstrate understanding of core data analytic topics covered by our expert instructors. As mentioned, not only will you be set up in a virtual environment, but our curriculum will have you working with open source tools and popular programs like Python, Pandas, Jupyter, Scikit-learn, and Tableau. So this is the part-time data analytics curriculum overview. If you would like it broken down by week, again, just email us at admissions@the-Data Incubator. Fellows versus scholars. We admit 2 types of students into our data science programs. Fellows are offered tuition-free scholarships to our full-time program. We offer a limited number of those scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our programs and are expected to interview exclusively with our hiring partners. Scholars will pay tuition to participate in our program. They are not required to interview solely with our hiring partnering network and may maintain their current employment. Scholars still have access to the same curriculum, resources, and tools as our fellow students. Full tuition scholarships are not offered for the part-time program. So we are so excited to announce our Data Analyst Diversity Scholarship Program, which aims to help remove barriers and provide opportunities for women, veterans, LGBTQ, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. This scholarship is only available for our full-time data analytics program and is not offered for our part-time program. So that is just a little bit about our program. I will now pass out to Michael to lead you through our live data science demo, and I will come back at the end to help answer any questions.
All right, thank you so much, Raven. I'm going to put this link in the chat one more time for those who may not have signed in the previous time that I sent it out. So in the chat, you will see 2 links. And I'm going to go ahead and pull up kind of what you should see. So I sent a link to a GitHub repository. This is the repo that we'll be working out of today. I also sent a link to mybinder.org. And this is what's going to give us an interactive Jupyter Notebook environment that we can use. So if we click on this, on the binder link, you will see something like this open up. This is starting up a container in which you will have an interactive Jupyter Notebook server. For those of you who are not familiar with Jupyter Notebook as an application, or I guess a file format and kind of a framework for coding and doing data analysis in Python, you're looking at one of these servers now that it's loaded up into this file tree. This is ultimately the type of server that we deploy all of our curriculum material and mini project assignments on. Although Binder is a little bit different from the one that we use. So mybinder.org and the Binder framework in general let us spin up like a very temporary Jupyter Notebook server from a GitHub repository that you can use and follow along with exactly the way that all the code worked when I wrote it. The server that we give you in the fellowship and in the analyst program are certainly like much higher performance and don't time out after like 10 minutes. But it looks a lot like this. Again, for those of you who maybe have not seen this sort of this program before. Now, in this file tree, I'm going to navigate into this demo1 pandas Excel folder. And then we're going to click on this notebook right here, GenerateReport. And you'll see something like this. I'm actually going to run this on my local machine, just so it's a little bit more reliable, I've found. But yeah, a little bit about today's activity. So this is a demo of some of the things that we teach in the course. As far as the format of this demo versus our kind of like lecture and curriculum material, I will say that this one moves a little bit faster, has quite a bit less explanation, and certainly does not get into a lot of the really complicated, well, I don't know about complicated, but a lot of the more cutting edge and more like data scientific techniques that we kind of get into. So this is actually wrapped up in some of the introductory material we see in our programs, but it's a great chance to see kind of what the format looks like and to see how we can use the skills that we develop in these programs to carry out and like automate real world tasks. So that's kind of what we're headed for today. Again, for those of us who maybe haven't seen Jupyter Notebooks too much, once again, you are looking at one right now. This is a very, very popular, really realistically like ubiquitous kind of format for coding in Python, especially for like data analysis and data science kind of experimentation. We have these little blocks of code that we can run. They're called cells. We also have cells of markdown text where we can write in Markdown and it gets nicely formatted. And so it's a great way to have kind of nicely written reports, examples, and notebooks and exploratory analysis and stuff like that. As we go through this, we want to make sure we're running all of our code cells because cells later on in the notebook will depend on stuff we do higher up in the notebook. To run those cells, if you're following along live, there are a few things you can do. There's definitely a run button up here at the top of this toolbar. You can do that if you'd like. I probably will not be doing that. I will be using the shortcut key, holding Shift and pressing Enter. So you'll notice when I did that, there was a little star in here for a second, and then a 1 appeared in that box. That's going to tell you that the cell has run. This 1 means it was the first cell that was run when I started up the notebook. If I run this again, which once again is Shift, Enter, that turned into a 2 because it just ran again, meaning it's the second thing that was executed. That's a little bit of a tour of what we're doing when we're moving through this notebook. Yeah, that's just to make sure those of us who are not as familiar are able to follow along. So format aside, we've got that down. Let's talk a little bit about the kind of context for today's demo or the problem we'll be working on. And so we will be looking at automating a little bit of reporting, computing and reporting some metrics as it pertains to kind of an influencer marketing problem type, but could appear in a lot of marketing situations. And so we're going to have some data coming in the form of Excel files. And these are going to show a couple of things. We'll have a sheet called posts in our Excel file. And this will basically log, when we in our hypothetical marketing team, each time we, pay for a sponsored social media post. And so it will have the influencer, the date, the number of likes, comments, shares, and things like that. And also their number of followers and so forth. We also have another sheet called conversions. And this will show, this person had a post, people clicked on it. This many people who clicked actually went on to convert, which let's say is basically like buying something on our website, right? So in posts, we would see people who click, but in conversions, we would see people who not only click, but actually go on to buy stuff. I actually have this loaded up in Excel so we can take a look at the raw data. So our posts spreadsheet looks kind of like this. So we have a date of a post, an influencer, number of followers, and I've grouped them by their number of followers, and then a couple of things we've recorded. So here, 52 people clicked on this hypothetical influencer, Rachel Kelly's post on January 5th, 2019. If we look at conversions, it's formatted a little bit differently, which means we'll have to work with that as we start processing this data. But we can see there's Rachel Kelly, and if we go over to January 5th, that's going to tell us that one person who clicked on the January 5th post actually went on to buy something. That's the data we're working with. We are going to compute some metrics for that to do a little bit of reporting, to give to, let's say, like the marketing manager. And so to do this, to load in these Excel files and process the tables and create a report and spit it back out as a new Excel file, we're going to use a library called Pandas, pretty much kind of another like ubiquitous Python library. Anytime we're dealing with data in tables, basically. It's very efficient. It's very intuitive. People use it all over the place. So let's get right into it. And again, if you're following along, make sure you run all these cells on the way down, because here we are importing packages that we will need later. So I'm going to specify the location of my data directory. I'm also going to make a new directory for the reports. And now I'm going to say, all right, so this is where I want to output, or I guess not report path, I should say data path. This is where my import data is coming from. It's in this directory, and this is the name of the Excel file. And I'm going to read that in. I'm going to say, all right, I want to make a posts data frame. That's like a pandas table. It's going to come from here. It is the, sorry about that. It is the first, I guess 0 is the second sheet in this Excel file. Again, conversions is first and then posts. So it's the second sheet. And we can take a look at what that looks like once we load it into pandas. And in a Jupyter Notebook, we get this nice kind of pretty easy to read HTML output for our table. So we see we've got all the same columns, and we're just looking at the first 2 rows here. So we have this date. We're actually going to convert that to a different data type. When we load it in, it's just a string of characters. Like if you literally just typed out those numbers and some hyphens, right? But we want to make that into a date time object. This is something that would let us actually do some date and, unsurprisingly, time-based processing. So we'll do that right here using this PD for pandas.toDateTime function. And we'll get into that a little bit more later for why that will be useful for us. So this is all set to go. We didn't have to do a lot of reformatting or anything on the posts table. The conversions table is a little bit more awkward to work with because we have that time, on the sort of each date is its own column. And we really would like something that looks like the posts table, right? Where we have a column for date. We want to get these 2 worksheets or these 2, spreadsheet pages in the same format where we have a column for date and a column for influencer. And then rather than, sort of this cell for the conversions, we'd have another column for conversions. And if we can get them looking the same way, we could imagine that we can join those 2 things together. That's what we're looking to do, because we're going to need to compute a couple of metrics for our marketing, kind of report. So I'm going to go through loading in that conversions table, and then we'll actually circle back a little bit, talk about the metrics that we are computing. So kind of the same thing again, read Excel. This time I'm using the first sheet in that file, and it's coming in looking like this. We have these funny looking NaN values, which is a missing value in pandas. We're going to fill those in with zeros. We would get something that looks like this. And we can see, ones on the days where someone posted, and then that one viewer who clicked on the link in that post actually bought something. Again, that's a conversion for us, right? And so we want to be able to take those conversions and tack them on to everything else we know about each post, because we want to know a couple of key pieces of information. We want to know how well these campaigns are doing, right? We want to know, should we be spending more money or less money on these influencers? Which influencers are particularly effective, ineffective? Maybe which months have we been doing better or worse? And so we're going to look at actually, I guess we're still headed that way. So first, let's talk about, merging these two tables. Again, we need to get them looking kind of the same, right? And that's because we're going to need to look at the conversions divided by the cost and the conversions divided by the clicks. Those are the metrics we're going to compute. We'll talk about that a little bit more in just a minute. So we need something that has a conversions column but looks like posts. And to do this, we're going to have to melt the conversions table. And basically that means we take this wide form kind of table where we have a separate column for each date. We're going to squish that down so we have one column for influencer, one column for date, and then we have one column for the number of conversions. Again, conversions looks like this to start. And if I say I want to melt that, it's going to end up looking like this. Oops. So again, influencer, date, and conversions. We went from wide form to long form. And now that it has corresponding columns and kind of a corresponding shape to the posts table, we're going to merge those two data frames together. So I'm merging posts with melted. And on the left, in other words, in posts, I'm using these two columns, date and influencer. In the right table, aka the melted table, I'm using date and influencer. But notice that here I maybe accidentally said influencer with a lowercase I. And in the original posts table, we have an uppercase I, but that's okay because we can specify, by name which columns should line up. So we merge those together. We're going to call that DF for data frame. And we've got something that looks like this. We have our date, influencer, all the stuff from posts. Influencer, again, technically we don't really need that. And we have conversions. So all of our data is kind of processed from the two sheets, reshaped for the conversions, and joined together so that we can start actually looking at some metrics that we care about. But before we do that, why don't we take the code that we just wrote to load in the data and merge them together and so forth. We're going to turn that into a function. If you're not super familiar with Python or with programming, basically what we're doing is we're condensing all of this stuff into a single kind of convenient command that we can run. There are a lot of reasons that that's a desirable thing to do when you're programming, but if nothing else, it is nice that we can just, read this little name right here and kind of understand conceptually what we're doing, with in this line rather than looking at, I guess, about 8 or 9 lines of code. So we have this function called load and preprocess. It's going to take in a file path where the original data is, and it's going to spit out that merged data frame. So now I'm saying our data frame is the output of our little function. And again, it's kind of that thing we expected. I've also added in this function a little bit of code that creates a new month and year column. So for instance, this now says January 2019. OK, so we're doing a couple of metrics here. One of them is going to be the cost per acquisition. And what this is it's how much we spend to get a conversion, right? So looking at our table up here, this column says that, here I spent $80 to have this sponsored post. And I want to know, like, well, if I'm spending $80, how does that divide out to the number of people who convert? So I paid 80, I got one conversion. One single person who saw this post not only clicked on it, but actually went on to buy something. And so looking at that particular single post, the cost per acquisition is $80, right? Spent 80, got one conversion. So the way that we compute that, unsurprisingly, cost divided by the number of conversions, because if I had 2 conversions for $80, the cost per acquisition would be 40. Now, we could do that row by row, but we also want to be able to group that in different ways, right? Like, what is my cost per acquisition I typically see for a single influencer, or maybe for a single month, or over a couple of months? And so we're going to write a little function that does that. It's going to take in our data frame. It's going to check that there are some actual conversions in there. And if there are, we're going to return the sum of all the cost, the total cost and everything, divided by the total number of conversions. So if I ran this on my data frame up here, I would actually get my average cost per acquisition over everything, which we could do, but we're actually mostly writing this so that we can look at this metric grouped by different columns. And that's kind of a fundamental thing we do in Pandas, is this kind of group by operation. So here, if I say group by influencer and apply cost per acquisition, this little function that we wrote, it's going to spit out something that looks like this. And so this says, for instance, for our hypothetical fake influencer, Albert Taylor, we are spending on average $29.09 to get someone to buy something. Maybe that seems like a good deal, maybe it doesn't, but comparing that to another hypothetical influencer, Amanda Campbell, we are spending about $800 just to get a single person to buy something for the sponsored posts that we are paying for them. And so we have that broken down by every single influencer. And I think we could imagine a few reasons this might be useful. If we see that some of our influencers appear to be very effective, we're getting a lot of bang for our buck, so to speak, that might suggest that we want to work with them more, or potentially, investigate what it is that, makes their posts or their audience, particularly, desirable. Maybe look for other influencers who have similar characteristics or a similar audience. And then when we see someone like, let's say, Lori Young here, who we're spending almost $1,200 for a single purchase, we might think we're maybe don't want to keep working with this person too much longer. So that's going to help us strategize, right? We can also look at the cost per acquisition over each month. And so we're seeing, for instance, that it was a little bit lower in February. If we combined this, we could actually go by month and, let's say like influencer. We could see something like this. Here's how everyone was doing in February 2019. I could also reverse the order of these things and say, all right, well, let's group by influencer first and then month. And that way I can see that, well, Albert Taylor did, a little bit better in February than in these other months. So we have a lot of flexibility. And that's, again, the idea of writing this using functions, is it gives us that flexibility. So that's our first metric, cost per acquisition. How much do we spend to get somebody to buy something? We'll also look at our conversion rate. And so this is going to take conversions just like we did before, but it's going to be conversions divided by clicks. So if 50 people click on some post, and out of those 50 people, 5 of them made a purchase, 5 divided by 50 means we have a 10% conversion rate. Number of conversions divided by number of clicks. So this looks very much like our cost per acquisition function. It just is using clicks instead of the cost. Now that means, for instance, I could take this little piece of code right here, and actually we'll get rid of that, and we'll just take a look at conversion rate. So I have my data grouping by influencer per person, and I'm applying that function. So I'm computing it separately on everybody. I can see those all reported out here. Now I could even go on to do something like sort these things. That would give me an ascending order. I could also say, I don't want ascending order. That would tell me my people who have the highest conversion rate. But it's still not really clear. Do I want the conversion rate or do I want the cost per acquisition? Because if we're still spending a lot of money for this person, then maybe it is or isn't better that their conversion rate by itself is higher. So we have to balance these things out. That's why we want to know both pieces. Because maybe we could find someone who has a similar audience, maybe where we could see a similar conversion rate, similar number of clicks, but we might be spending a little bit less. So that's why we want to see these metrics broken out a couple different ways. And to work with our marketing manager or director who wants to see all this stuff, we want to be able to adapt the report that we give them to the things they want to see. And that's, again, why we're writing the code in a very flexible way. And so to take all of this and to make it as flexible as possible, let's now take those little functions we wrote and create a new function called GenerateReport. And what this is going to do is it's going to, given our data frame and given a column that we want to group by, such as per month or per influencer, we're going to get the cost per acquisition for each influencer or month, the conversion rate grouped by that column. We'll also look at just the total cost, clicks, and conversions, and the total number of posts. And so we'll join those all together, and it'll look something like this. So now all in one table, using just a couple short functions we wrote, here we've grouped by influencer, and we have posts. So Albert Taylor, we only had 8 posts. So maybe it's a pretty small sample, perhaps, but we actually got 33 conversions out of those. So we're only spending a little under $30 per conversion. Seems like a pretty good deal. And we could use that a lot of different ways. I'm going to shorten this a little bit. And so if I took this and I said, let's sort this by cost per acquisition, not in ascending order, so descending order, well, that would report out the people with the 5 highest costs per acquisition. And again, that's going to be pretty helpful for us. Now, we've got a function that can group by a column, give us all of these nice metrics, but we're not quite done yet because we don't want to give our manager a notebook like this. We want to give them something they're familiar with, that they're, maybe can do further analysis with, or be able to play around with the data. And so we brought this in from Excel. We want to write it back out to Excel because our collaborators are going to be, probably used to working with Excel. So now we have one more function, write report to Excel. And this is going to take an input path. It's where the data is, and an output path. That's where we're going to put our new sheet. So we're doing kind of everything that we've seen so far. And actually, here's a little typo. I will be sure to update that on GitHub. So we read in our posts and our conversions. We're going to pre-process that data. And we're going to then look at influencer grouping, month grouping, and influencer and month grouping. And what you'll see down here is that we're actually writing each of those separate reports grouped by different columns into separate sheets in our output file. And then we're saving that file and it gets saved to our file system. So now I've got this, and you'll notice that this is using all the functions we wrote so far. Load and pre-process brings the data in, merges it together. Generate report for each of these grouping columns. Generate report is using the cost per acquisition and conversion rate functions. And then again, it all saves out to a new file. So now we can create our entire report from some input path and send it out to some output path. So if I run this, oh, and actually that's not looking quite right. I think I may have changed a few things as I was going through this on my local machine earlier. So this is done running. We take in that input path where the original sheet lived, and we spit out a report into a new Excel file. I'm going to switch back to Excel really quickly. So this was our input data and our posts and our conversions. And I know I've got a lot of files open right here, but this is kind of what we spit out. It's a very basic report. We haven't done anything like actually putting any visualizations in here, which we actually have the capability of doing, even making Excel graphs natively and putting them into Excel like in an automated way. But we see that we have a couple of different reports, one by influencer, one by month. You can kind of see, I guess it's pretty zoomed out, and one by influencer and month. Now, I didn't go to the trouble of automatically formatting what these columns look like when I output from pandas, although this is actually another thing that we can do with Python and pandas. I was just keeping, kind of our functionality a little bit simple, but in fact, in the fellowship and analyst program, we'll see a lot more cool stuff we can do with pandas and a lot more stuff we can do with pandas writing out to Excel. So what was the point of doing all of that and putting it into a function? Why not just write it all front to back and just run the whole thing? Well, making it a function makes that code portable. It becomes very easy to reuse it on another file without having to, dig through our code and make sure everything's working. So now I'm going to say, cool, I want to make another report. We were looking at Q1 2019 before, so January through March. Let's do another one. I have another spreadsheet of data for Q2. And this one looks the same. It's just new dates. Starts in April, goes through June. But all the same code that I used before, in just about a second and a half, I read in that file, wrote the report based on all my metrics I calculated. And again, I know I have a lot of files open here, but that's so that I don't have to wait for them to open. And this is what our output ends up looking like. Now, it looks exactly the same in format as the last one, unsurprisingly, but again, this is looking at different months here. So now we have a little bit more going on. And that's going to be the main content of our demo. Again, wrapping up what we looked at. We looked at a task we might want to do for making a, I guess in this case, a quarterly report. Look at the effectiveness of our influencer marketing campaigns. To assess that effectiveness, we computed two kind of quick metrics. How much do we spend to get somebody to buy something? And also, of all the people who click, what proportion of those actually buy something? And we wrote this in such a way that we could group it per influencer, per month, per influencer and month. And if we wanted to do different groupings for those same metrics, we could very easily. And then we made it sort of portable so that we could use that function on new data when the time comes. Something that we could go on to do with this, and actually that we have some of the files for in the other directory in the repo that I sent you. We can actually take that and start turning all of this stuff into an interactive web app. And so this is something that we can actually deploy and give to someone on the marketing team. They could drag and drop their Excel file in and they could see a report on screen. So that's kind of our next step, right? We can start doing some rapid prototyping with the notebook, with an Excel report. We can start, turning that into more like an interactive report using a program called Streamlit, which I discuss in a future demo. And we could even envision going from there to making a fully automated dashboard. And that's the sort of thing we talk about in the analyst program using Tableau, and in the fellowship using Streamlit and Flask. So it's this sort of process by which we can, start easy, start fast, keep iterating with the people we collaborate with, to make sure that we're actually meeting the things that they need in their reports and applications, and then continue to, reuse our code, basically copy and paste this function into, new and more powerful frameworks without having to redo a lot of work. And again, I will say that we kind of cover a lot of ground pretty quickly in this demo, and I don't really explain all of the code kind of and how it generally works. This is not what the pacing really looks like in our lectures, but we have a lot more time in the lectures, so this is just a demo. And that's going to wrap up the main content. We'll have some time for questions at the end, but for now, I'm going to turn things back over to Raven.
Thank you. There we go. All right, so moving right along, employment rates. So a big component of our program that we really pride ourselves in is helping our students not only grasp data science concepts, but also getting placed in that field. Our analyst program is brand new, so we don't have any data yet there, but our data science fellowship program, 97% of the students that go through our program are currently employed outside of academia, and 82% are employed within 6 months of completing the program. So again, just to repeat myself, 97% of our students that go through our program are currently employed outside of academia, and 82% are employed within 6 months of completing the program. Those are really great numbers. We're very proud of those and have worked very hard for them. That's part of the challenge. Not only learning content, but being able to transition into data science roles. That's really where our program stands out, because we help you do both. So where are our graduates now? Again, data is not available for our analyst program just yet, but for our data science fellowship, this would give you an idea. Our graduates are working in 55 different industries. Some of the most common industries we see are computer software, internet, IT, financial services, and biotech. Some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. These titles and roles vary depending on the company and industry, but these are some of the roles that we've placed in the past. So here's a short list of some of our data science fellowship hiring partners. Many of these companies are also hiring for data analyst roles as well. But we are also focused on building a separate network of hiring partners dedicated solely to our data analyst program. Financial assistance. Many of you were asking about our financial options and if we offer assistance, and the answer is yes, we do. In addition to our scholarships, we have partnered with Leaf to provide an income sharing agreement. It's great. You can participate in our program with just a deposit down, and you won't be required to make any payments until you've graduated and are working and earning more than $40,000 annually. We also provide loans through Ascent, and Ascent offers 3 different options. So their first option is a deferred repayment, which means that you will be responsible for no payments during the program and for 3 months after. The second option is interest-only repayments. And this is just small interest-only payments during the program and for 3 months after, and then you'll start making those full payments. The third option is an immediate repayments. So you'll just begin making full payments 1 month after the program begins, and they have 36-month and 60-month terms available. Lastly, for many of our part-time programs, many companies are willing to sponsor or pay for their employees to go through our program. It's a win-win. You get to learn great stuff in the evening and be able to apply to your job during the day. If this is something that you think your company would be interested in, or you would like to present to them, we do have a letter we can provide you that will help you lay out the program and all the benefits to attending. So just some important dates, where we are right now. Well, we run multiple cohorts a year, and our summer cohort just started classes, but our application for our fall cohorts is now open. Our fall cohorts will run from September 20th to November 12th for our full-time program, and then September 20th to February 4th, 2022 for our part-time program. As I mentioned earlier, the full-time cohorts are 8 weeks long and the part-time cohorts are 20 weeks long. Some specifics about the data science application is we ask that you submit your application by July 30th for our data science regular admissions. You'll then have 72 hours to complete the coding challenge from the time you open it. The challenge deadline is August 2nd. So although you'll have 72 hours to complete that challenge, please keep in mind that August 2nd is the hard deadline, so you will still have to have the challenge done by then. You cannot complete the challenge unless you submit the application. Just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We are unable to reopen the application or challenge after that deadline. So for our data analytics application timeline, it's the same deadline. Our application deadline is on July 30th, and the decision will be made on August 20th for our optional diversity scholarship and the interview. If you're interested in applying to our program, which I hope you are, you can go to the dataincubator.com/apply to submit your application. If you have any questions about your specific situation, this presentation, or going through our application process, please reach out to us at admissions@thedataincubator.com, and we'd be happy to answer your questions. So that's going to end the presentation. I just want to open up the floor for any questions. See if you all have any questions in the Q&A box. Give me 1 second. So we have someone asking about location, if they apply for the fellow program and employers do not hire them at all. So if you apply to the program and you're selected as a fellow, you'll be working with our partnership team closely so that you can secure a job with one of our hiring partners. Even if you're not a fellow, keep in mind that our scholars have the same opportunity as our fellow students. So you will all be working closely with career services to make sure that they understand what you want. You'll have interviews so they can understand what you're looking for in an employer, and then they'll help bridge that gap between you and hiring partners. So as long as you're participating in class, you're doing everything you're supposed to do as far as having your assignments submitted and working closely with our hiring partners, I don't foresee a problem with helping secure employment. Of course, we have hiring partners all over the United States and some with remote positions, but your flexibility of being able to relocate has a lot to do with you being, I'm sorry, I have other questions coming up, but your flexibility and being able to relocate has a lot to do with you being able to go to the partner that you would like to go to. So I guess it just depends on your flexibility of being able to relocate. Okay, and if I have any other questions, go ahead and add those to the Q&A box.
There's a question, Raven, that I saw in the Q&A that I think we had clicked answered on, but I don't think I addressed it.
Okay.
So you asked if there was any specific reason that I used OpenPyXL in this notebook. Is it an industry standard, or does the data scientist or analyst have full autonomy on choice? So yeah, and so that shows up when I'm reading in the Excel file, and I'm saying that the engine we're using to read that in is a library called OpenPyXL. There are multiple engines you can use with pandas, but to my knowledge, OpenPyXL is the only one that currently works with SLSX spreadsheets. It's like a slightly newer file format Excel uses. And it's kind of the default one since 2007. So that's just the only reason that I'm using it. It doesn't really impart any like noticeable difference in what your data frame looks like. We just need to have it installed because of this particular type of Excel file.
So I see a couple more questions popping up. So 1 second, we have a couple more minutes to answer those. So does the part-time data science program also offer scholarships? So no, in the PowerPoint, I mentioned that you can only qualify for the scholarship if you're full-time. So all of our scholarships and our fellow spots only apply to our full-time students. And something that help our program stand out is the fact that we dedicate so much time to career services. We want to make sure that you not only leave with knowing those data science concepts, but we want to make sure that you're placed with a hiring partner when you leave. So a lot of our time is dedicated to the curriculum, yes, but a lot of time is dedicated to networking with hiring partners and networking with the partnership team so that you can be placed with a partner. And I think it's another question for you, Michael.
Oh, yes. So Shay, you asked if you can fork the GitHub repository. Yeah, you absolutely can. Feel free to fork the code and work on it more. Yeah, like kind of on your own. That's, all in the spirit of open source.
All right, we have somebody. What is a code? What is the coding challenge? So the coding challenge is a part of the admissions process. In the admissions process, you're going to be expected to complete an application and upload your resume. After you're done with that part, you're going to be asked to start a coding challenge. So you'll have 2 weeks to begin that coding challenge after you submit your application and 72 hours to complete it. Keep in mind that the deadline is August 2nd to have their coding challenge completed. So the only people who will be receiving a coding challenge are the data scientists. If you're applying for our data analyst program, then you're not required to do a coding challenge. And of course, you just need basic programming knowledge in order to complete that coding challenge. Although Python is our preferred language for the coding challenge, you'll be able to use any programming language of your choice. Okay, I have a couple more minutes for a few more questions. So it does not matter on where you're located or your visa status, you are able to apply to attend the Data Incubator. Keep in mind that that is going to come into play when it's time for you to be placed with a hiring partner, seeing as though most of our placements we focus on most of our placements within the United States. So I would definitely consult with an immigration attorney for any immigration questions that you have. But to answer your question directly, you could participate in our program for anywhere you are. Right now, we are online, and we're not looking at in-person sessions until next year. And I'm just going through to see if I have anybody else with any questions. See any hands or any questions? All right, so I do want to reiterate that if you do have any questions, if you just think of any questions when we're done with the presentation or this live session, then please be sure to email all of your questions to admissions@thedataincubator.com. I'm pretty sure you all have received probably several emails from that inbox by now, but just reply to an email or just send us an email with any of your questions. And if it's not for our department, we'll be sure to get that to the right department. And I'm not going to hold you all any longer. If you're done asking all of the questions that you need, it was a pleasure being able to speak with you all today, and just everyone have a great day.
Yeah, likewise. Thanks, everybody, and take care.
Bye.